guys, this is Malinki. Welcome back to my channel Voice of Malinki. Today we will talk about students t-test, and if you are new in my channel, please subscribe my channel, and if you like my video, please do like, comment and share my video. So before defining students t-test, we will see an example first. Suppose we have two data sets. One is this, which contains values such as 1, 2, 3 and 4, and the other data set is this, which contains values such as 6, 7, 8 and 9. Now we want to determine whether these two data sets are different from each other or not. So in order to do so, you have to perform a statistical test. That is nothing but a students t-test. Now let's define students t-test. Students t-test is used to determine whether the two sets of data are significantly different from each other or not. In other words, students t-test is used to estimate whether to accept or reject null hypothesis. We have studied null and alternative hypothesis in our previous lecture. If you want the link, I am putting it in the description box. So briefly, if there is no difference between these two data sets, null hypothesis should be accepted. No difference. Null hypothesis should be accepted. And if there is a significant difference between these two data sets, null hypothesis should be rejected. So if difference is there, null hypothesis should be rejected and alternative hypothesis should be accepted. Students t-test got its name from William Seeley Gossett, who first published it in 1908 in the scientific journal Biometrica, using his pseudonym Student. Because his employer preferred staff to use pen names when publishing scientific papers instead of their real name, so he used the name Student to hide his identity. So this is the formula for calculating t-test. Here this S del bar is this, where the x1 bar is the mean of the first set of values, x2 bar is the mean of the second set of values, S1 is the standard deviation of first set of values, S2 is the standard deviation of second set of values, N1 is the total number of values in the first set, and N2 is the total number of values in the second set. So the formula for mean is this: x bar is equal to summation of x divided by n, where x is the given values and n is the total number of values. And formula for standard deviation is this, where x is the given values and x bar is the mean and n is the total number of values. Now let's solve this problem. So for the first set of data, find mean and standard deviation. So mean x1 bar is equal to summation of x1 divided by n1, where we can get the value 2.5. So in this column, we have values of first data set which are represented as x1, that is 1, 2, 3 and 4. In this column, we will subtract the mean, that is x1 bar, from x1 like this. in this column, we will just make the square like this. Then here we will add all these values, that is 5, that is summation is 5. Now we will calculate the standard deviation or S1 for the first set. So we know the formula now. So the standard deviation for the first set of data is 1.3. We will do the same thing for the second set of data. So we get here the standard deviation is 1.3. This is the formula for calculating t-test that we already know. Since we know the standard deviation of both data sets, we will calculate S delta bar here. So that is 0.9. And the t-test value is now minus 5.5. Now let's conclude our findings. So when the null hypothesis is true, a t-value should be near 0 and less liable to extend further from 0. T-values near 0 indicate more similarity between the two data sets, that is, the data sets are similar. T-values further from 0 indicate a large difference between the two data sets, that is, the data sets are different. So here we have found t-value is minus 5.5. That means two data sets are different since minus 5.5 is further from 0.